So looks like everything is good. So let's start our webinar. So guys, a few words about the chat. Most of the time the chat will be switched off. Sometimes our moderators will turn it on. But of course, if you have any questions, we will have a time for your questions. There will be a link to the Google form where you can send your questions, and after my speech, I'll try to answer for all your questions related to RAID data recovery. So guys, so let's start. And a few words about our company. If you're first time here and you don't know who we are, just a few words. We have a lot of solutions for HDD, SSD, flash drives, and mobile phones data recovery. We have solution for damaged storage media, not just only for health devices, but for damaged devices. So you can check our YouTube channel, check our blog, and so on to get more information. And we are actually leader in data recovery field, so I hope you will enjoy the information. A few words about me. My name, I'm Alexander Leonenko, and I'm leading data recovery engineer in ACE Lab. I'm working for 13 years, and RAID data recovery is one of my specializations. So today I'll try to share my knowledge to you and to show you what is a modern RAID data recovery is. What do we have for today? We will discuss the myths around RAID data recovery. We will talk what is a RAID array, what are the main issues in RAID data recovery, and of course, I will show you how we can solve all these issues using PC3000 software. And I will show you step-by-step guides. And of course, to demonstrate, we will have a real cases, examples. And as I said before, after the end of the speech, there will be time for questions. And before we start, I have a question to you. Do you deal with a RAID array? If yes, please type yes to the chat. If no, but you plan to, please type plan. If you don't, please why? So, yes, I can see that a lot of already work with the RAID arrays, and someone plan. Yes, one more plan. Okay. When we ask such questions, we usually can hear some myths about RAID data recovery. What are these myths? The first one, it's that RAID data recovery is something hard and time-consuming. That it's only for gurus. And what else? That it's rare and doesn't pay off. It's expensive. And today I will try to show you that all these things, they actually myths, but not really truth. And let's talk what is a RAID array in general. If you just first time in RAID data recovery, just a few words about RAID arrays. So what is a RAID array? It's a abbreviation that means a redundant array of inexpensive or independent drives. It's a storage virtualization technology. You have a few physical drives, and instead of these physical drives, you get one virtual drive that has some characteristic that is better than characteristic of one drive. For example, RAID can be faster, RAID can be more reliable, and RAID can be can have bigger capacity. And just for example, here you can see RAID 5 from a free drives. And how do we get reliability? RAID 5 stores special blocks to be able to recover any drive in case drive will be excluded from RAID array. So if one drive doesn't work, RAID 5 still can work. RAID 5 works faster than one drive because input and output operation can work in parallel. And RAID 5 actually has a bigger capacity. The capacity of RAID 5 from free drives is the size of 2 drives. So using a free drives, we get a new storage, virtual storage device that has some better characteristics than just one drive. But what are the main data recovery challenges when we talk about RAID data recovery and forensic investigation from RAID arrays? They are, it's a RAID imitation, damaged drive in arrays, configuration detection, very important issue, also configuration checking and redundancy related issues like an outdated drive, rebuilds and reinitialization or something like that. And today I'll show you how to solve all these issues using our PC3000 RAID system because it's the easiest, fastest and the smartest solution for RAID data recovery. And I will show for each issue, I will show you how it can be solved. And the first issue, it's a RAID controller imitation. Why do you need to imitate RAID controller? Because sometimes, for example, just drives okay, everything is okay, but just the controller is died and you don't have the same one. Or maybe if we talk about forensic investigation, you are not able to use drive in this controller because you have a requirement to prevent any writings to these drives. So you have to use something else, somehow to imitate work of RAID controller without controller. And there are a lot of reasons why RAID controller may not work. Maybe it's operating system issues or something like that. So sometimes we need to imitate RAID controller. And PC3000 system give you ability to create any popular configuration and any custom configuration in Data Extractor RAID edition. The second one issue is the damaged drive in array. And what if we have damaged drive in RAID? What can we do? No, there is a direct approach. Just make a full copy of damaged drive. This approach is good when your drive is quite stable, but if you do a lot of data recovery from HDD drives, you know that sometimes it's quite a difficult process, and this process requires a lot of time, a lot of spare parts. Maybe you need to change to read the most important data at first, or maybe to read drive from 0 to the end. Of course, we need important data. Yeah, for example, we need some database file or something like that, and we have to start to read this file at first. And Data Extractor RAID edition give you ability to do it. Using the software, what can you do? What are the steps? You need to build virtual RAID array in Data Extractor. Then you need to make map of important data. What does it mean? To select sectors that contain important data. Then you can translate these sectors from RAID to the damaged drive and read only these sectors from a drive. So, and when this process will be finished, you will be able to save important data from the RAID. So, and now we have a real case demonstration. I will show you how to recover data in case if you have a damaged drive in array and how to create a custom configuration. So here I have a drive. This drive has some beds, and I will show you how to and I will show you how to recover data from the RAID that has a damaged drive. Give me a second, I will connect this drive to the EC3000 SATA 0 port. So everything is okay, and let's power on the drive. So drive in a busy state, let's wait. So drive ready. Of course, if you talk about damaged drives, what you usually do, you need to go to the utility, make a resources backup, maybe to solve some firmware related issues, maybe do something else, but today we are focused on RAID arrays, so I'll skip all these steps and go to direct to my task. I'll open a data extractor, and here is a task. I already have 2 drives in my task, 2 other drives from this RAID array. So you can see 2 healthy drives, and now I will attach my damaged drive. It's on a port 0. So next, when we work with damaged drive, we use making data copy, and let's by default. So my drive is here. Right now, let's suppose that we know the configuration. Yeah, and my configuration is a RAID 0 start 2048 start LBA. So here you can see the form where I can set up all RAID parameters. So right now I know all the parameters, and this is a RAID 0 and block size 1024. So let's save this configuration. Yes. Oh, and let's quit. So here is my RAID that contain damaged drive. I can open the file system, and let's suppose that everything that I need is just read these images from a desktop. So the first step, I need to create a map of important files for me. So this one, let's make this map. Then I need to translate this map from a RAID to a damaged drive. I use this menu and go to my damaged drive. It's a SATA 0. Here it is, and select all. Okay. So here is the sectors that I need to read to be able to save important pictures for me. So now I can, let's, for example, order them from by start LB, and let's run a reading process. Let's run it in the background. Yeah, and right now you can see that the software read data. There are some bad sectors, so we data extractor send a software resets and so on. And let's go back to the data. When this process will be finished, I'll be able to save this data. So let's try to check. So all sectors are green, so I am able to save this file. Yes, everything is okay. So what's the main idea? You don't need to make a full copy of damaged drive. You can make copy only important sectors. So it's just an approach how to work with the damaged drive in RAID array. What else? When we talk about custom configuration, here on this form you can create a lot of different configurations. So RAID 5, for example, you can set delay, you can change a block size and everything else. But for example, sometimes you may have some kind of exotic configuration. In this case, you can manually change this table. This table is describes the rule how RAID is works. So, for example, recently in my practice there was very strange RAID, but I've done it, and we were able to save the data. So, how it works? So it was 2 rows in a table, and there was 6 data blocks, and the table looks like here 0. I'll delete this one. 0, 1, 2. Here was a XOR block. Here also was a XOR block. 3, 4, 5. And XOR was calculated like this. So it was really strange configuration. I've seen this configuration only one time in my practice, but you can create it and you can successfully save the data. So it's about how to imitate RAID controller. In case if you have some kind of strange configuration, you still can create custom configuration and save the data. So let's stop the reading and let's close this task and go next. The next, one of the most important issue when we talk about RAID data recovery, one of the most interesting is configuration detection. And here we have 3 main approaches. The first one, conventional, automatic, second one, and the manual. So let's discuss. And just a question for you. Have you tried to row in a boat? Yeah, I think it's a very nice hobby, but what if you need to go from point A to point B and the distance between these points is quite big? I think it's very hard. You have to be very well prepared. I mean, you have to be in a good physical form. You have to learn a lot about navigation and other stuff. So, for my opinion, the conventional approach, it looks like a rowing in a boat. Well, so what does it mean, conventional approach? You have a lot of hex editors. You learn how to metadata looks like in a hex editor. You try to get some values from special places inside this metadata, and then you use spreadsheet to save you thoughts about RAID configuration, and using all these things, you try to understand how RAID is work. What is the block size, what is the RAID level, and so on. So this approach will require a lot of time, and it will require a lot of knowledge. So that's why I think it's like you're the only one who rowing in a boat. But of course, today I will not talk about the conventional approach. I will show you how to use data extractor rate addition to get results easier. And in a rate system, we usually use two approach. You also can use conventional approach. There are tools, there are multi-hex editors and so on, but usually we use two approach, the automatic and the manual, or it's better to say semi-automatic. I will tell you later why I think semi-automatic is better name for this mode. So let's talk about the automatic methods. Automatics, they are very nice and cool. Why? It looks like a journey in a cruise ship. Yeah, everything is done for you. Just press button and relax. So, and automatic by metadata, what are the advantages? No, at first, it's fast if you talk about auto detection by rate metadata, and it's very easy to use. But what are the main disadvantage? This method doesn't work for all cases, unfortunately. And it's not because we have, I don't know, bad algorithm or something like that. No, it's just because there are a lot of reasons. Metadata can be damaged. Metadata can be overwritten. I mean, if the new configuration was created, the metadata will tell you wrong information. Rate may not contain metadata at all, or maybe format of this metadata is very sophisticated and no one except the manufacturer know this format of metadata. So the automatic methods, they looks like a journey in a cruise ship, but not all arbors are accessible. Not all cases can be solved by these methods. So, and what if automatic methods don't work? What should we do? Go back to the conventional way, to hex editors, to spreadsheets, and so on? No. Data extractor provide you next one method, manual or semi-automatic method. And let's discuss. From my opinion, manual method, it's look like you are captain on a ship with a well-coordinated team. Why? Because all routine is automated. You get high-level reports that give you high-level information about the rate configuration. And it's much more easy to get important data about the rate configuration. So, and what are the steps? What are the main steps how to use manual mode? The first step is preparation. What should you do? You need to activate entropy map for all members, and then you need to run row recovery for all members. This step can take some time, maybe a few hours. Yeah, but important things that actually these steps do not require your attention. You just run the processes and you can do other cases. The next step is a step when we analyze the results. And there are three main modes that we use to analyze results. It's a rate member report, rate member statistics, and row recovery. And the last step, it's a final detection. On the previous step, we make one or maybe a few hypotheses. What does hypothesis mean? We need to understand what is the rate level, what is the block size, what is the start LBA, how many drives do we have, and what else? What is the host file system on the RAID? And the final step, we have to detect the members order and the algorithm. For example, RAID 5, RAID 6 has algorithms like left synchronous, left asynchronous, and so on. And these two things, drive order and the algorithm, will be detected on the final step when we fill the table. And let's go to the real case demonstration, and I will show you how automatic method works and how to use the manual method. So let's go to the software and let me open the task. Here I have copies to save space on my drive. I made a copy of image in a compressed format. So that's why you can see these messages. So here I have 6 drives and how to use automatic methods. You go to RAID creation form, this one, and just run this mode. So configuration was detected. So, and now we can, only one configuration was detected. Sometimes you may see more than one configuration, but right now it's only one. So configuration detected, all parameters are applied, and you can see, yeah, you can see that right now data is accessible. So everything looks okay. So it's very nice and very easy and very fast. But what if we can't use the auto detection method? I mean, what if it doesn't work? Let me demonstrate how detect the same configuration using manual mode. So, and let's start from the preparation. As I said, you need to activate entropy map for all drives. So this menu, activate background filling for entropy maps. Yeah, entropy maps were activated, and software asked me to run reading to fill this map. Right now, I don't need it. Why? Because I will, then the next step, you need to run raw recovery processes for all drives. Yeah, so you can see that raw recovery is running. So I will stop it because raw recovery is already done for this task. In real life, what can you do? You can wait when raw recovery will cover about 10% of space, or maybe just leave it for 1 or 2 hours. And after that, you can go to the next step, to the analysis and making hypotheses. And what should we do? The first mode that we use, it's a RAID members report. Here you can see our members, and here you can see some algorithms that use different approaches to get some information about RAID array. For example, this one. This approach try to find structures and try to calculate the distance between these structures on RAID and real distance, distance on physical drives. And depends on the ratio between these two distances, we can get some information about RAID array. For example, here you can see that we found ext metadata. Actually, they are ext superblocks. And this algorithm tell us that it can be RAID 0 with the 4 drives, or maybe RAID 5 with the 5 drives, or maybe RAID 6 with the 6 drives, and 10 from 8 drives, 5, 0, 6 drives, 608 drives. So we have some hypothesis about RAID level. And what else? Also, you can see that we found X file system, and this file system occupy 100% of the RAID. So looks like it's something that we want to see the file system where our data is located. And this one looks like a false positive results. Why? Because some X superblocks may be located inside the journal. So that's why they have a wrong position. And when we calculate, we get some really strange value like 45. Of course, this hypothesis looks like not real for our case. What's next? We can run RAID member statistic based on row recovery. This mode analyzes how data in row recovery is located on each drive. It analyzes a lot of patterns for different RAID configurations. And what can you see? For all these members, what was detected? We detect that block size 256. RAID table must contain 6 rows. Each column must contain 2 service blocks and 4 data blocks. And there is a pattern how these blocks are distributed. So underline means service block, and this pound or hash symbol means data block. So this pattern looks like pattern for a RAID 6. Yeah, and here you can see the hint. So it can be RAID 6 from a 6 drives, or maybe RAID 60 from a 12 drives. So, and what should we do? We just need to get our hypothesis together, yeah, and make the result hypothesis. So we can guess. Here we had information about RAID 6 from 6 drives, and also here we have the same information. We have information about the block size, 256, and the last thing that we need, it's what is a start LBA. We can go to the row recovery mode and try to find a good structure that can be the beginning of the RAID. What you usually see at the beginning at the RAID? Actually, it's the same thing that you can see at the beginning of the drive or at the beginning of the partition. What are these structures? It's MBR, it's superblocks, boots, and so on. So let me check what do I have here. So here I have the MBR. This MBR is quite big. Yeah, it's about 4 drives. So, and it's located on LBA 0. So my hypothesis is that start LBA is 0 because I found MBR here. What else? Here I have X superblock, but actually I need to find superblock from group 0, like this one. This one is from the journal, so it will not suitable for me. But I can go to the different drives and try to find, for example, this one. So my next hypothesis is that start LBA is 512 because this superbox is shifted onto 1024 bytes from the beginning. So I have 2 hypotheses, but actually MBR hypothesis about LBA 0 because we found MBR on this position is much more better than hypothesis about LBA 512. So we have everything to start to fill our table. So we have 6 drives. They are here. Start LBA is 0. I don't need to change it. Yes. Then I'm going to detect RAID 6 configuration. I don't know the algorithm, so leave it just anyone. Delay 1. What else? The block size is 512. We detect it. And I don't know the drive order and I don't know the algorithm. So this table high probably in real life, because you don't know the algorithm and you don't know the drive order, table, of course, high probably will not be correct. So I will clear this table. And my final step is filling the table. We start filling the table from detected service blocks. In the RAID members report, you've seen that we detect where data blocks and where service blocks are located on each drive. Yeah, so and we can move this information to our table. So data extractor detects this. These two blocks, they are service. What does it mean, service? It means it's maybe XOR or maybe Reed Solomon. I don't know. Maybe this is XOR, maybe this is Reed Solomon, or maybe it's Reed Solomon and this XOR. So, and let's go here. And right now, what do we have here? Here you can see the table. It's almost empty, and the drive. Drive on the left, use table on the right to translate the data. And what should we do? We have to make a good translation. What does it mean, good translation? It's translation that give us ability to see the data. So, and when I select the drive, data extractor try to find structures that can be at the beginning of the RAID. So, and data extractor found that you can see the cell highlighted by red. Here we found an MBR. Also here we found MBR, and also we found the MBR. But we already know that this block must be service block. This also must be the service block. This block does not contain anything related to the beginning of the RAID. So we have only one choice, and let's put block 0 here. Right now you can see that data extractor puts some more blocks. How it works? Data extractor analyze all possible RAID 6 configurations, left synchronous, left asynchronous, and so on, with a different drive order and so on. And for all this configuration, when we talk about tables, yeah, that that has service blocks here and block 0 here, we can say all this configuration contain block 1 here, block 2 here, and so on. So data extractor puts these extra blocks just because right now we are thinking that we detect something standard. If you work with some kind of exotic RAID configuration, you can switch off this option, compare with the standard configuration, and data extractor will not put these blocks. Yeah. Because exotic configuration is not standard, and for exotic configuration, this option will not help you. But most of all, it helps us to detect the configuration. Because right now I have MBI at the beginning, I can open the list of partition. Here is only one partition. Partition start at 2048. And what can be at the start of partition? It can be boots, superblocks, and so on. And data extractor try to find good structure. And you can see that here was found ext superblock. Let's wait a little bit. Here you can see that this is a ext for superblock. Here also and here. Yeah, but right now we have the only one choice, this one, because these blocks must be the service. So maybe XOR, maybe Reed Solomon. I don't know which one exactly. So let's put it. And right now data extractor fill all other blocks, all other data blocks. Why? Because we already detected that we have RAID 6 or maybe RAID 5 EE left synchronous. Actually, the last thing that we don't know is what are inside these service blocks. So let's check. So you can see the data. Why? Because service blocks we actually need when we recover some data. Right now, we do not recover any damaged drives or any bad sectors, so we do not use them. And actually, we are able to see the data here. But for example, if one of your drive has a bad sectors, it's a good idea to detect the role of these service blocks, and we also can do it. So there is an option, try to detect the role of known blocks. Yeah, and now you can see that our configuration is detected, and right now we can say that yes, it's a RAID 6 left synchronous. So our configuration detected, we can save it and continue our data recovery process. So it's quite simple, not very simple, yeah, because we have 6 drives and RAID 6 configuration, but using all these modes, we were able to detect it very, very easy. But I want also show you one more task. Yeah, and before I will show you, I'll also show you the RAID member statistics. Sometimes, for example, if you work with a hard case and maybe you want to check, yeah, maybe you have more than one choice here, yeah, and you want to get more detailed information about data distribution on the drives, yeah, you can go to RAID member statistics mode and get a little bit more detailed view. So what can we see here? If I select the block size 256, I'll see the pattern like this. And what does this picture mean? The blue histogram, it's a data distribution based on raw recovery results. And this histogram says that block from 0 to 256 does not contain data. Looks like it's XOR or maybe Reed-Solomon block. The next one contain a lot of data. Next one data, data, and data. And the last one does not contain data. It's all about drive A. The green line is the entropy map. We can also calculate entropy distribution for a member. And if you look on this distribution using this window size, we can also say that first block has a higher entropy than this block, then this block, and this block, and this block. And the last one block is also has higher entropy level. Why? Because usually XOR and Reed-Solomon has higher entropies than data blocks, because these blocks are some kind of combination of data from data blocks. So statistically, in most of the cases, not for every one sector, but if we take statistics, we can say that service blocks contain data with a higher entropy level. So let's go to the next case. A little bit more tricky, yeah, because you may say that this case is quite easy. And I want to show you the power of this approach. Tricky config. So what do I have here? Here I have 3 drives. Okay, I don't know what is the RAID level, how many drives was in the original RAID, and so on. Just the 3 drives. Auto detection doesn't work, and what should I do next? I go to the manual detection and preparation step, entropy map, row recovery, and for my task it's already done. So let's go to the RAID member report. And let's check what do we have here. Let's use this algorithm. Right now we can see some kind of strange result. We found NTFS metadata, and the distance between structures has ratio 1.31. It's something strange. For a RAID arrays, it must be like a 2 or maybe 3 or maybe 4 or something like that, but not 1.3 or not 2.55 or something like that. Yes, so what this result is about? Looks like it's data from a virtual drives. So right now we can say that this file system is not interesting for us. Let's go next. Now you can see that this algorithm detect very interesting information. What do we have here? For all drives, we detect that block size is 128 and table must contain 64 rows. Inside each column, inside this column, we have 16 service blocks and 48 data blocks. And the distribution looks like this. So, and here you can see the hint. So it can be RAID 5 with a delay 16 with the 4 drives. And also a few other hypotheses like a RAID 5.0 with the 8 drives and so on. They looks like not match for our case. Why? Because we have only 3 drives. So if it's RAID 5.0 from 8 drives, we must ask our client where all other drives. Yeah, but right now my hypothesis that we have RAID 5 with 6 drives, block size 248, and we also have a delay. Let's go next. There is another one algorithm. It try to find structure where we can find some size of some data. For example, here we found the boot NTFS, and inside the boot NTFS we can find the size of this file system. We get the size and divide it onto size of the drive, and we get ratio 0.54. So it's not very informative. It can be just on a simple drive, I mean on a drive not in the RAID, or it can be mirror or something like that. But also I have another one group. I found the MBR, this one, on the LBA0, and this MBR describes some data that is 3 times bigger than size of my drive. And also I found the VMFS volume info. Also this structure contains information about the file system, and size of this file system is almost 3 times bigger than size of my drive. So, and here you can see the recommendation, the hypothesis. So it can be RAID 0 with the 3 drives, RAID 5 with the 4 drives, RAID 6 with the 5 drives, RAID 10 with the 6 drives. So I take this information and this information together and make my main hypothesis. And what is hypothesis? I have a RAID 5 with the 4 drives. It means 1 drive is missed. I don't have it. Yeah. The block size is 128. I have a delay 16. And the start will be is 0 because here I found the MBR. So I get all this information and I can go to the final step, to the filling the table. So 3 drives already here, but my RAID contained 1 more drive. Yeah, and here is just a placeholder for this drive. This drive is missed. I don't have it. Start LBA is 0, so I don't need to change it. So what's next? I'm going to detect RAID 5, delay 16, block size 128, but I don't know the drive order, so I can shuffle these drives. Yeah, and I don't know the algorithm. So I will clear the table, and now we are going to fill this table and to detect the final configuration. And the first step, detect service blocks. No, you can use row recovery or maybe entropy map. So let's use this one. So we moved information about blocks distribution from the RAID member report to our table. And you can see our service blocks. And let's go to the Explorer. And again, here you can see that we checked what can be at the beginning of the drive. It can be, for example, MBR. Here I found the MBR. Let's put this block here. And again, we analyze all standard RAID 5 configurations and for the configuration that contains service blocks here, here, and so on, and contain block 0 here, we can say that all these blocks must be located here. Okay, let's refresh and go inside. Here you can see that some VMFS file system found, and let's see. Right now, I select the folder, and the folder point me to some metadata. And this block does not contain metadata. This one is empty. This one contain, and this one is not contained. So only this choice is possible. So I will put it here, and my configuration was detected. And let me show you. Let me, for example, this one, and here it is. So let's reopen the file system. Yeah, now I can add a virtual drive because you can remember that we have some NTFS metadata, and I want to show you why do we have this NTFS metadata. Because one of the virtual drive, or maybe not only the one, contain NTFS file system, so this metadata can mix up us when we will analyze data on the drives. So what's the idea? This case, when I have this case a few years ago, when we do not have a RAID member report, when we do not have a RAID member statistics, it was quite a difficult case. Why? Because I tried RAID 0, I tried RAID 5 from 5 drives without delay, I tried a RAID 6 with how many 5 drives, and all these attempts failed, and only then I tried RAID 5 with the 5 drives with a delay. So I've done a lot of work, and I get the result, but right now you can see that it's much more easier to find out that you have one more drive missed, and actually you have a delay here. So let's close this task. Okay, and before we go to the next topic, to the next issue, I have just a question for you. let me open uh, let me open this this task. So here I have 3 drives, and I detect, no, for example, you detect this configuration. I don't know, maybe we use some kind of auto detection method, or maybe client said you all the parameters, or maybe you use the manual mode and detect this configuration. And what do you think? Is this RAID good or not? Yeah, for example, I can try this picture. This picture is nice, but if I try this one, looks like this picture is damaged. So is this configuration good or not? And let's go to the next issue is configuration checking. Like for this example, RAID configuration is detected, but some data is damaged. Or maybe sometimes RAID configuration is detected, but you can't see the data. Why? Actually, there are a lot of reasons. For example, you could not see the data because files were deleted, or maybe some data at the beginning of drive were damaged, and that's why you can't see the file system. Or maybe a few drives in your RAID have a bad heads, so maybe no, you don't have all data, and some metadata is damaged, so that's why you can see damaged files, or maybe damaged file system. But actually, maybe your configuration is not right. Yeah, so there are a lot of reasons. And in real life, of course, you may have not the only one reason. You may have some reasons together. So what should we do? How can we check our RAID configuration? How can we be sure that configuration is good? No, at first, to solve all issues on the RAID, we must solve them in a special order. Yeah, and what are the steps? At first, you have to show that configuration is good. Why? Because if configuration is wrong, you will have damaged file system, you will have damaged data in any case. Yeah, even if everything else is okay, wrong configuration, wrong data. Then you also may have some redundancy related issues. For example, like an outdated drive in the RAID. I'll tell about this issue later. And you need to check these issues on the second step. Because if your file system looks like damaged, if you solve this issue, you may get a good file system without any other actions. And only the last step that you need to do is apply approaches for common drives. I mean, RAID also can contain deleted files, can have a lost partitions, can have a damaged file system, and only on the last step you need to use approaches for a common drive like a file system analysis, raw recovery, and so on. But the first step is check RAID configuration and detect the right configuration, then solve redundancy related issues, and only then common drive approach. And how to check RAID configuration? If we just see files and folders, it doesn't mean that we have good configuration. How to check? There is a rule. You need to check big file. But what is a big file? How many? What does it mean big? 1 megabyte or 1 gigabyte or I don't know 64 kilobytes? What does it mean big? The big file is a file that bigger than your table. So what do you need to do? You need to see how many data blocks inside your table and multiply it on block size. So, and you will get size for a big file. For example, on the picture on the right, you can see RAID 5 for a free drives, and the pattern is repeated. The table contain 6 data blocks and 3 service blocks. So for this configuration, we will take 6 blocks. And the second question, how to find big file? I mean, sometimes it's easy. You just open the root of file system, go to the first level folder, and you may see the files that big enough and files that you can check. But sometimes it's quite difficult to find these files in the tree. So you can use file system analysis, and then you will able to use grouping or filter to get only big files that you can check, or you can just run raw recovery and see, do you have big files inside raw recovery or not? So let me show you. Let's go back to this task and let's see. So I'll switch on header controls, and you see that header is good, file is big. So let's calculate what is a big file. So let's look on a table. So here I have 6 data blocks inside my table, and the block size is 128 sectors. Let's calculate 6, 28, and the sector size. So this size in bytes of our big file. And let's check. This file is smaller than a big file, and that's why when I open it, it's good, but it's not a big file. Big file is something like here. And if I try to open this file, yeah, you can see that this file is damaged. And if you try to open another one files, yeah, you also can see that all these files are damaged. Of course, even if you detect the right configuration, not every one file must be good. Yeah, but usually it's quite easy to find good and big file. Yeah, so for this configuration, I'm not able. I can't find a big and good file. So looks like my configuration is wrong. But let's check another one configuration. This one is a RAID 5 write synchronous. And this one RAID 5 left synchronous. So if I go here, so this file is much more bigger than I need, and let's try to open. Yes, everything is okay. So for this configuration, I can be sure that everything is good, but for this configuration, it doesn't work. And for example, if I run raw recovery for this drive, you can see that big files were found. If I found raw recovery for this drive, for this RAID configuration, there are no big files. So the big file is a good test how to understand, do you have right configuration or not? The next step, we try to solve redundancy-related issues. But before we start to solve, at first we have to understand, is it possible to use redundancy or not? You have to ask, does RAID level support redundancy? Yes, and how many drives can be excluded for this level, and how many drives are already excluded? The second step, you need to understand, does it make sense to use redundancy? For example, if you take very simple example, RAID 1 mirror. Mirror is just two copies. One drive contains copy of another one drive. So data on each drive must be the same if everything is okay. So, for example, you detect that this configuration, you open the data and data is damaged. Does it make sense to try to read data from the second drive? If second drive contain absolutely the same data, there is no sense because you will get absolutely the same damaged data. But if second drive contain different data, maybe this data will be better. And the same idea, for example, for a RAID 5 or a RAID 6. You can check the integrity. If integrity is okay, it makes no sense to use redundancy because if you exclude drive, you will get absolutely the same result, the same damaged data. So it makes no sense to use redundancy to get better result. But if integrity test bad, you can try to exclude drives and maybe you will get better result. You will have different result, but it doesn't mean that it will be better in all cases. And the next step, my recommendation from my experience, if you can use redundancy and it make sense to use redundancy, I recommend you check an outdated drive issue. Why? Because it's the most common related to redundancy. And if you don't have an outdated drive issue, only then we can start to try to understand and try to solve issues like destructive rebuild, reinitialization, and so on. And let's talk in detail. On the left picture, you can see RAID 5, free drives, all drives are healthy, or maybe you've done a copy of these drives. So for this RAID, you can make a redundancy test, and also you're able to exclude one drive. So for this RAID, you can use redundancy to get different result. On the right picture, you have the same RAID 5, but one drive is missed. For example, this drive is unrecoverable or something like that. So in this case, redundancy already used to recover, to restore data of this drive. So we are not able to check redundancy, and we can't exclude one more drive because RAID 5 does not allow to do it. It allows exclude only one drive, but not two drives. So for RAID case, we are not able to use redundancy to get different data. Okay, for example, you're able to use redundancy. The next step is understand whether it makes sense to use it. And there is an integrity test. What can you do? There are a few approaches. The first one is check integrity for the whole RAID. Actually, it will get you accurate answer. How many sectors on the RAID has a bad integrity? How many exactly sectors? So it's very accurate, but it will require a lot of time because we need to read the whole RAID. What are the different approaches? You can make a random subset of sectors on the drive, or maybe it's better to make a used sectors map on a file system and get some random sectors from a used sectors map. This approach is much more faster, but it's kind of probabilistic. Why? Because if there are a lot of sectors with a bad redundancy, you high probably will find them. If there are not so many sectors, yeah, there is a chance that you will not see these sectors. So it's a kind of compromise between speed and accuracy. And the last one approach is you need to find a recently created file and check redundancy for this file. This approach usually quick and usually accurate. Why? Because it's usually not so difficult to find recently created files, and for many cases, for example, for an outdated drive issue, you will see do we have redundancy, do you have sectors with a bad integrity or not? Because we will discuss a little bit later, recently created files, in case of outdated drive issue, must not have good integrity. Yeah, they always will have a bad integrity. And let's talk about outdated drive issue, how it happens. We start from a healthy RAID array. All drives are healthy, RAID work fine. We write some data to this RAID, some files, everything is okay. In one time, drive C is excluded, but RAID still, no, if we talk about RAID 5, for example, RAID still working. Yeah, it works in degraded mode. It maybe try to say that something was happened, but no one know. It's a typical situation in real life. And RAID is still working without drive C. And all new data that was written since this time to the RAID will not be written to the drive C. So drive C will have not a valid data, yeah? And the final step, one more drive is excluded, and only then you will have this RAID in your lab. So what if you build RAID configuration with all drives? Yeah, of course you will detect drive C may looks like a good drive. Why? Because it was in this RAID. Yeah, it contained the same data distribution, the same data block, everything is good. Yeah, but data, since drive C was excluded, and it can be a few years actually, it can be just a few hours, but it can be a few years. All new data will not be on drive C. So if you try to save these files, these new files, they will be damaged. So that's why it's better to not use this drive when you create the RAID. And this issue, we call it outdated drive issue. It's quite often in real life. And how to find? The first issue with outdated drive is how to find what drive is outdated. At first, you can try to exclude drives one by one, and if you can see that something becomes better, maybe your choice is good. I mean, maybe you found the outdated drive. If you can't see is it better or not, you can try recently created file. Yeah, why? Because right now we know why this file will be damaged in case of outdated drive. So you need to find our recently created files and try to check them. They will be damaged, And you can try to exclude drives and see do you have a better result or not. And the last one approach, in case if it's kind of difficult to find a good file that was recently created, and or maybe you are not able to understand is result better or not, because sometimes you exclude one drive, some folders are missed, some folders new, exclude another one drive, and result is also changed. So sometimes it's not so easy to understand. There is a statistical approach. You will grab information about all files and try to understand do you have outdated drive in a statistical way. And how to solve? Just don't use this drive in the RAID. Yeah, let redundancy do recovery process for you. Yeah, for example, if you have RAID 5, you exclude one drive and XOR blocks will be used to recover good data for a outdated drive. And let's go to real cases. Let's see how to check RAID configuration. We already done it. Yeah, I showed you that we can find a big file, we can check it, and we can be sure that configuration is good. So right now I will show you how to do redundancy test. Redundancy test say us is it makes sense to use redundancy or not, and how to find an outdated drive. So let's close this task. So here I have how many? 5 drives, and RAID 5 from 5 drives, and here I can see some data. Does this RAID is good or not? I don't know, so let's try to check a big file. So let's calculate what is a big file. So here I have 20 data blocks in table. Let's calculate 20. Block size 128 sectors, and sector size, so 64 kilobytes. For this task, big file is 64 kilobytes. Okay, let's try to find such a big file. So this file is almost 4 megabytes. It's much more bigger than we need. So let's try to check it. So everything is okay. So right now I can be sure that my configuration is good. What does it mean? It means that it's actually RAID 5, it's actually left synchronous, the block size, start LB, and the drive order. Okay, let's go next. If you go to this folder, you can see some headers are not valid. Okay, some files looks like damaged. And let's check file here. Can try to open it. File is damaged. Okay, let's try to open this file. It's also damaged. Okay. So at first, I know that my configuration is good, yeah, but the second thing that I still have damaged files. So maybe I have redundancy related issue, and maybe I can solve it. So let's make our analysis. We have a RAID 5 and all drives here. So for a RAID 5, we can exclude one drive. So, and because all drives here, we can use redundancy. Okay, we can use. But does it make sense? I've told about redundancy test. So here I can check integrity for the whole RAID, or I can use a random subset, or I can check recently created files. So let me show you. So for the whole RAID is here. Yeah, you can set the start and final LBA. And you can see that a few sectors has a bad redundancy. So right now we found that we have sectors with bad integrity. And we can say that if we exclude one drive, we can get a different data. Yeah, but sometimes you may see that this process can require a lot of time. Yeah, what the different approach? We can make a used sectors map for the file system and make some select some sectors from this map. For example, like this. I get some blocks from this map and check integrity for this map. Yeah, and you also can see that there are a lot of data with a bad redundancy. So the same answer. We have sense to use redundancy. And what else? I can make a file system analysis, or I can try to find the next step. I need to find recently created files. I can just observe the file system, or maybe I can do a file system analysis and group files by date, for example. But let's open the map of this file, and if we check integrity for this file, here you can see that there are a lot of sectors with a bad integrity. So, can we use redundancy? Yes. Does it make sense? Yes. So, the next step, we have to find an outdated drive. We don't know, do we have outdated drive issue, but if we try to find and try to solve it, and if everything will be okay, I can say yes, it was an outdated drive issue. So how to understand which drive is outdated? The first approach is try exclude drives one by one. For example, I will exclude drive B, and let's refresh the data. No, and I'm not sure that it becomes better. Okay, I will exclude drive C, and let's refresh it again. Some files becomes green, some files still red. And if I exclude drive A, yeah, now you can see that everything is green, and if I try to open it, yeah, everything is okay. So it was a first approach, but sometimes you are not able to use this approach. So what can you do? For example, you can make a file system analysis for NTFS, it's scan-MFT, for example. Then for this result, you can use grouping. And for example, you can group files by creation date. This is just not a real task, it's just for an example. So that's why I have only 2 days here. So here you can see recently created files. And what else can you do? You can check. So now you can exclude one by one, or another one approach, you can see where files with bad headers, where they located. So this file, like header located on drive A, block 10, drive A, block 15, drive A, block 5, drive A, block 15. So looks like drive A is outdated. And again, if I exclude it, everything is good. And the last approach. So let's close it. So sometimes it's not so easy to use these two approaches. Yeah. Sometimes you may have quite a big file system tree, a lot of files, but not all files you can check. So there is a statistical approach. To use it, we have to fill RAID members map. It's a first step. So on the RAID, you can fill RAID members map. And let's do it in the background. Second step, we need to fill file system validity map. You need to select the file system and there is an option. And also I'll do it in the background. And here, what can you check? You can check metadata for some file system. You can check headers and bodies. We don't need bodies. We just metadata and headers is enough. So, and let's run this process. So you can see that so process are finished. And how to analyze. Let's open the map of the RAID. Then switch to, for example, this map or this map. I create this map and this map. You can choose any one. For example, this one. This map tell us what is the source of each sectors. For example, blue sectors located on a drive A. Yeah, red sectors located on a drive C, and so on. So go to this menu. We need to calculate map statistic from another map and select the second map. In my case, second map is a file system validity map. So calculation is going on. So now you can see such a table. What can we get from this table? On the left, in the rows, you can see that information about members. Blue, drive A, this drive B, drive C, and so on. And in the columns, you have information about from a file system validity map. Valid headers, invalid headers, valid metadata, and not a valid metadata. So, and what's the idea? We can check how many valid metadata or valid headers on each member. And what is most important, how many not valid headers and not valid metadata on each member. And now we can see that drive A contain 512 sectors with a not valid metadata. Drive D contain only one. So drive A is a leader, yeah. What else? Drive A contains 70 invalid headers. Drive C contain only one, and drive E contains 77. So we can easily see that looks like drive A contain most of invalid metadata and invalid file headers. So it's the first candidate to be an outdated drive. In case of outdated drive, usually we can see that one drive is a kind of leader. Yeah, only one drive contain almost all invalid headers and invalid metadata. In case if you have not an outdated drive issue but something different, this statistic will be all drives will contain something close values. So, and again, from this table now I can say looks like drive A isn't outdated. So let's close it and let's go to the RAID creation form and let's exclude this drive. I switch off the mark from the drive A. Let's save it. Okay. And also you actually can use file system validity map to understand the quality of your result. For example, if I will run this, fill in this map for the new drive, and I will also run rate members map filling. Yeah, we can try to look on the same table again and try to see what was changed. Do we have better result or not? So all process finished, and let's open. No, and again, the same step. Map of the rate. Switch to this one or this one. Let it be rate members map. Then go to map statistic from another drive and let it, we need file system validity map. And let's analyze. What do we have? Now, to make table a little bit easier, I can hide default values and empty values. Yeah. So now you can see that drive A contain only one invalid header, and drive C also contain only one. Drive C also contain one sector with a not valid metadata, but there are about 2000 sectors with a valid metadata, there are about 1000 sectors with a good headers, so looks like everything is okay. Of course, when we talk about a statistical approach, we can have some not a valid headers, some not a valid metadata. It's just a real case. Not everything must be valid. Yeah, but you can see that there is no such thing that one drive contain about, I don't know, 10% of headers is not valid, or maybe 10% of metadata is not valid. Yeah. So for this case, I can say that everything is okay and it was statistically approved. So guys, so we already discussed how to check an outdated drive and how to solve outdated drive issue. So let's go back to our myths. I hope that today I prove that some of these sentences are myths. Yeah, so is rate data recovery is hard and time consuming? I hope that right now you know that there are steps that you should do, and there are a lot of modes in data extractor that can really help make these steps easier. So the truth that rate data recovery is in most of cases is highly automated. Is it only for gurus? I don't think so. If you even if you have any difficult cases, you still can contact our technical support. Yeah, but the steps that I showed in this presentation, they applied for most of your cases, and usually they will help you to get the result. Is rate rare and doesn't pay off? No, actually you can go to the market and check what are the prices to rate data recovery, and actually one or maybe a few rate cases can cover all your expenses. And the last one, very good thing for you, you may think that it's expensive, but now I can say that not anymore. Everything that I showed you today, all issues I solve use PC 3000 rate set system. It's a best solution for HDD and rate data recovery. Why? Because here you have PC 3000 Express, It's a best solution for HDD data recovery. And also you have a data extractor and data extractor RAID edition. So it's a best solution for RAID data recovery. And now we have a very good price for this system. If you earlier, if you check the price of such a system, yeah, and right now you can scan this QR code, and email to our sales department will be generated, and our sales guys will share you information about this PC3000 RAID system and about the price. And I have to say that this price, I'm sure it will surprise you. So guys, scan this QR code, or you also can just write an email to our sales department. So today we learned how to handle damaged drive in RAID array, how to detect configuration, we test automatic approach and manual approach. And now I think you understand why it's better to call semi-automatic approach. Yeah, we discussed how to check the RAID configuration and why it's important. And also we learn how to find and how to solve an outdated drive issue. And I hope I prove that RAID data recovery is not so hard. Yes, so that RAID data recovery is easier, faster, and is easier, faster for you. And if you ask our sales department, yeah, you will also know that it is more affordable for you now. So guys, now it's time to questions. And again, here you can see our site and the sales department email. And let me open. So let me open your question form. So the first question, does RAID system support unRAID and GBOD and ZFS file system? Yes, unRAID is a kind of combination of GBOD and RAID 4. So we are able to create such a configuration in our software. No, actually, what you need to do, if all drives are healthy, you can create just a GBOD and get data. If one of the drive is damaged, you can create a special drive that will contain result of recovery of this drive using redundancy. Yes, GBOD is, we support these levels, and ZFS is also supported. But what's the difference? Today I were talking about, how to say, classic RAIDs. What does it mean? Classic RAIDs, it's when you have tables that and this table is the rule of translation. If you talk about ZFS RAID Z1, 2, or something like that, it's not a classic RAID. All translation is inside ZFS metadata. So we support it, but it's different kind of storage. No, and actually you may also have classic RAID with a simple ZFS. I mean, you have, for example, RAID 5, and on this RAID 5 you have ZFS and ZFS things that file system have just a simple drive. So we also support this configuration. So you have PC 3000 UDMA with SSD. Can you upgrade to RAID? Yes, you can upgrade to RAID. I mean, you can buy data extractor RAID to your PC 3000 UDMA. But for to work with the SAS drives, you need PC 3000 SAS system. So will RAID work with a SATA RAID? Yeah, actually PC 3000 Express, what can be inside your RAID? Actually, you can attach almost everything drives that you can attach. So you can use drives attached to motherboard. So it's USB, SAS drive if you have special SAS adapter, NVMe, USB, and so on. Also, file images, I mean raw image, E01 image, everything else. If you have damaged drives, you need a special board. So if you have damaged SATA drive, you need PC 3000 Express to work with a damaged SATA drive. If you have damaged SAS drive, you need PC 3000 SAS drive, sorry, PC 3000 SAS board to be able to work with SAS drives. Of course, we support NAS configurations. No, actually, almost all NAS storages, they are simply software Linux RAID. So NAS is actually computer with a Linux, and there is a software RAID inside. And it sometimes they use one software. For example, they use MD ADM utility. Sometimes, if you talk about OpenZFS or something like that, they use a different software. So we support NAS. So what is a Reed-Solomon and what is entropy? Reed-Solomon is special blocks these blocks we need to be able to recover the data. So there are XOR blocks. So XOR block just contain result of XOR operation of data blocks. Reed-Solomon has a different algorithm of calculation. Why? Because to be able to recover two drives, not just only one, you need two different service blocks. And the entropy. Entropy is a measure of chaotic. Well, what does it mean? How we use it in data recovery? For example, if sector contain all zeros or maybe all FF bytes, it will have zero entropy. But if sectors we take it from encrypted storage or maybe from compressed files, we usually say that it's like a white noise. Yeah, this sector has high entropy. And when we calculate this value, we analyze it. And there is a rule. We take it from a practice. Yeah, it's not a kind of rule of nature, yeah, but from our practice, usually service blocks like XOR, like Reed-Solomon has a high entropy level, and we use it to understand where the service block is located. So if you have RAID 5 with the 5 drives and 2 drives dead, can I recover some data from this case? No, actually, yes, but result will not be very good. For example, RAID 5 with the 5 drives will contain 20 blocks in the table. Inside these 20 blocks, you will not have 8 blocks. So For example, just in each, I don't know, 20 megabytes, you will not have 8 megabytes inside somewhere. Yeah. No, actually, if you talk about RAID array, it will be not a megabytes, it will be smaller values. So, of course, you will be able to recover small files that smaller than a one block or maybe smaller than a two blocks or something like that, but all big files will be damaged. And also file system high probably will be damaged because some metadata will be on the dead drives. So, of course, something you can get, but result will not be good at all. Can we have this webinar video to study it with attention? Yes, we are making a recording. If everything will be okay, we will share this record with you. So let me check. So guys, looks like we've done with the questions. I was glad to see you here, and I hope see you soon. Come to our RAID trainings. So, guys, it was a big pleasure for me to be with you. Bye bye.